Hello and welcome back. We're chapter 21, gas metal arc and flux core arc welding principles. Main objectives. Then we will look at the gas metal arc process, commonly referred to by welders as MIG. MAG, I haven't heard it referred to as MAG very much, but MIG is still a very big one. Wire feed as well, you know. MIG stands for metal inert gas, which was the original version TIG, tungsten inert gas. However, they wanted to kind of solidify all the technical info within the title of it. So for example, gas metal arc welding, it is an arc welding process. It's not a fuel or a chemical. It is an arc welding process. Gas, meaning it's got an inert gas to it. Metal cord wire, arc, and it's a welding process, not a brazing or soldering. Okay? So, introduced to industry in the 50s, limited by high cost, consumable wire electrodes, relatively crude wire feeding systems back in the day. Now, things have changed a lot. It's used principally for welding of stainless steel and aluminum. Especially aluminum. It's a few different things. We'll start talking about some fuel differences, or some gas differences, I should say. So for certain stainless steels, we need to make sure that we're running a trimix. For aluminum, we need to make sure we're running argon. Filler metals are a big difference. Shielding gas for the stainless steel as well. Anytime we're welding, we need to make sure we have a purging gas on the backside of our stainless steel welds to make sure we're not getting oxidation into the root. It's very crucial, especially in food, beverage, pharmaceutical, so forth. Nobody wants to get sick. It's important that we have a high quality weld on the backside of a stainless steel weld. So in order to do that, we need to create some sort of a back purge along the weld. In the shop, we've got some purge boxes. We'll be able to tape some stuff up. In the real world, sometimes you're using balloons, balloons and duct tape, or a rice paper situation that may clog up. You put some water on it and it kind of swells up, but then it can be flushed out of the system. It's not harmful to the piping. It will break down into small, like a rice hole type situation, be flushed out and dumped out. A lot of different methods that we can use, okay? Today, it's one of the more flexible all-around welding tools in fabricating industry. It's one of the fastest, most economical as well. There are some limitations, as with anything else, there's limitations, there's also advantages, okay? First of all, gas metal arc welding. In this case, we're talking about shielding. Same thing. So to begin with, here's our contact tip. Okay. We have the electrical current, the conductor comes down, it's what sends the signal. And then we have the wire, and then we also have our shielding gas. Okay, so the first part comes in, the electrical will send the signal here at the contact tip. Your electricity actually takes place right up here where the wire leaves the contact tip. Okay, this is also one of the places you're going to notice that you're going to run through a lot of contact tips. It's considered to be a consumable product. Okay, the shielding gas comes around it, creates a gaseous shield. Depending on which mode of transfer, the wire hits the material, it melts, creates solidification, and coming along further and further as we go. Okay. Now this one shows the direction of travel as so you're dragging it, and I would stick with for the most part I try to drag it. Now naturally in vertical position I'm going to push it. It can be in a drag or a push. A lot of gas metal arc welding, excuse me, the main mode of transfer that we use is short circuit transfer, and it's very crucial that you stay at the leading edge of the puddle, and we'll talk about it a little bit more here in a few minutes going through this chapter. But it can be a drag, or it also can be a push. as you're welding it. So in this case, if we're welding this way, you could turn this welding MIG gun around and weld going forward. There might be some different techniques we're going to use in that application as well. Okay? Now the flux core arc welding. This is an amazing process. Really, it's pretty amazing that this is more industry standard. You're going to see this more in a shop, especially, and even outside some too. In heavy industry, heavy material, heavy metal, because you're getting a combination of wire to where you can put down, you can save a lot of time, put down a large amount of deposition and filler metal, but you're also getting an external and an internal shielding gas if you're using the flux core arc welding gas shielded type. So there are very few issues with fusion, because it's a great penetration welding process, and you have some issues with the normal discontinuity, slag, so forth, but it welds hot enough and the puddle is liquidy enough that it usually cleans very well to the surface. Okay, so in my opinion, flux core arc welding gas shielded is specifically also commonly referred to as dual shield. So you've got a flux core and gas shielded. It's amazing. It's good welding. It's a lot more welder and user friendly than shielded metal arc welding is as well. And you can use it outside with a little bit of a breeze. You can turn your gas up some, build a little temp for it. It's usually, if you get the right filler metals, you know, Lincoln 71M, some of the ESOP 71 Ultras and so forth, you know, you can weld outside with a little bit of a breeze, and they don't trap the hydrogen in them nearly as bad as just a straight gas metal arc welding, just a solid core wire would. Okay? So, with certain flux core electrodes, the need for external shielding gas is eliminated. So that's the difference right here. Let's look at this. Flux core arc welding, the S stands for self-shielding, the G stands for gas shielded. Okay, so that's what we're talking about. Need for external shielding gas could be eliminated. Here's my experience. This stuff can be very rough. It can be done good. You're going to learn, you're going to run some of this in our shop as well. But for the most part, it's very smoky, it's hot, it doesn't look as nice. We're going to be more concerned, for the most part, with this right here. Okay? Flux core arc welding gas shielded. What we have is we have a tubular wire, so a hollow wire. The outside's the electroconductor, and there's flux on the internal portion of that core. Okay? As it's melted, the flux melts with it, plus you have an external shielding gas. So you can see here, I should have transferred to this one right there. In the center there's the flux, external shielding gas, and so forth. So the only difference here between if you're looking at a picture and trying to decide which arc welding process it would be, the self-shielded would be very similar, except for you wouldn't have the shielding gas. Okay. Again, we have a contact tip, a consumable, especially with the amount of heat that comes out of flux core electrodes. You do run through more contact tips and more consumables. The end of the contact tip will, with any wire, whether it be gas metal arc welding, flux core, stainless, or anything, what happens is instead of being a nice round hole, as it starts to wear out, you're going to notice that that hole starts to become more ovaled and elongated. Okay, and usually what you can do is you can turn your MIG gun up at the beginning, you can clip the end off, you can look at it, and you can grab the wire and see how much movement's there. Now there's going to be a little bit, there has to be a little bit. It's not a machine tight fit or a press fit. Okay, but what we don't want to do is we don't want to see a lot of it. Okay, and as you get some experience, you'll see, and going forward, and that's usually the place I start to troubleshoot what goes wrong with most wire-fed machines as well. Okay, if I start having to where it doesn't sound right, you know, we're getting a hesitation or kind of a popping on the wire and the sound, and everything should be fairly close. And I've known, set the machine right, everything else. First thing I'm going to do is I'm going to turn it up. I'm going to look at that contact tip right off the bat. If it's loose, it's going to create an issue. So the contact tip needs to be tight. Plus, we need to make sure that the hole is not elongated and ovaled. We also need to check and make sure our wire is feeding out right and smooth without getting trapped back and forth, okay? And then we can start looking at things like, is the shielding gas right? Is the material right? Is the voltage set up correctly? Or the amperage, so forth. Same thing as gas metal arc welding. The only difference is the filler metal is a tubular cord wire instead. Usually a larger nozzle for some more gas flow. Okay. Now here is your example of the self-shielded wire. You notice there's no external shielding gas. The only gas shielding is from the flux itself. And the guns are different too. They should be. You can run a self-shielded out of our dual shield gun. However, it gets really, really hot, and it should be the long external, it's got a really long external neck on it. And that's what you should be running to help protect yourself from the heat as well. Excuse me. So let's look over this real quick. Common things we need. We've got our ground. We always need a ground, and we always need a hot piece, right? So we've got a positive and a negative, or vice versa, depending on what filler metal and what it calls for as far as polarity. We have a wire feeding mechanism. We have to have a power source, which is the welding machine. Sometimes the power source and the wire mechanism can be in the same machine. Sometimes they're separate, okay? And then we also have to have our external gas as well. Now this is for, same thing, flux core or gas metal arc welding, they all need the same. Very few systems that I know have coolant systems within them. Some large welding processes of thermal arc and so forth that you're really putting a lot of weld down, quite possibly do. But for the most part, you're not going to see a coolant system on your gas metal arc welding machine. Okay, so let's go to the book. Page 675, chapter 21. Left-hand column, about halfway down the left-hand column, start out the paragraph. The complete name for GMAW is gas metal arc welding. Slang and trade names are often applied, such as MIG and MAG. Okay? We want you to finish reading through that section. Let's skip over and let's make a bolded point of the flux core arc welding process in bold. We go into talking about the process started gaining industrial use in the 1950s for the express purpose of improved metallurgical properties derived from the flux and the slag that supports and shapes the weld bead. Again, this is also where we get a majority of alloying as well. Okay? So we can get a filler metal, we can add some chromium, so forth. And that's why I think flux cores really gained some popularity in the past, is you can add the options of alloying. Putting the chromium or the magnesium or whatever you desire within that flux, that granular flux on the inside of the tube, as well as running the metal. And you can weld 4 or 5 feet in a row without having to stop. If we were doing that with shielded metal arc welding, it'd be about 6-7 inches. Stop, clean it off, go forth. I've welded several 4 or 5 feet welds with flux core and GMAW without having to stop at all. Being aware of my heat input and so forth as well. So the main thing that's really important as well is that you're adding some alloying content and some chemical materials to enhance the properties of what we are welding and fabricating. Okay, back to the book. Page 676, left-hand column, first paragraph down. Some of the electrodes generate sufficient gas shielding and are thus referred to as self-shielding. FluxCore Arc Welding -S. They act much like an SMAW coated electrode turned inside out. Okay, I'm going to skip down to the next paragraph. It describes the FCAW/G. Another FluxCore electrode requires an external shielding gas. These electrodes are referred to as gas shielded. They typically run on DCEP and have very good penetration and fusion characteristics. They also tend to have greater welder appeal and produce less smoke than the self-shielded type electrodes. A very common trade name for these type electrodes is dual shield. And that's what you're mainly going to hear referred to as in the field. Okay? So you're not going to hear a lot of, well, do FluxCore or FCAW. On the print, you'll see that, but you want to be looking for FCAW-G or S. But most of the time when somebody tells you, I just weld that up with dual shield. Okay? That's what you're going to hear. And that means FluxCore arc welding gas shielded. Alright? Moving on. Let's talk about advantages. Produces high quality welds at high speeds. We're reading off the PowerPoint now, sorry. Produce high quality welds at high speeds without the use of flux and limited post-weld cleaning. Very desirable for both small and high production joining. Frequently replaces another joint process such as riveting, brazing, soldering, or resistance welding. So now we're back to GMAW, gas metal arc welding. Used instead for the following fusion welding processes: oxy-acetylene welding, shielded metal arc welding, several others. Okay. One of the benefits with GMAW is high production, especially for thinner materials. You know, especially with GMAW versus gas tungsten arc welding, you have some more flexibility. So if you have a little bit too wide of a root opening, usually with gas metal arc welding, you're able to kind of fill the gap and make it still be a nice cosmetically a pleasing weld. Okay, it's going to look good, and you're going to keep the distortion down because it's not as hot as FluxCore or stick welding. So you're going to keep the distortion to a minimum. Light fabrication. So if I'm welding something like 1/8 inch or thinner, I'm usually going to try to take and weld it with GMAW. I'm going to get it tacked up. I'm going to tack it up and get my root opening right if I can. Make sure everything's square and straight as we start with. And then what I typically try to do is I will try to weld with it downhill. And more than likely, you know, by the time you've seen this video, you're in welding too. We've been through some downhill welds. I can make a very nice rippled appearance, and it's a fast weld. I can cover the gap if it's a little too wide. And it also reduces the amount of heat input that I put into it, therefore controlling the distortion and the warpage. Okay, so that's usually what I'll try to do. That's one of the good benefits of it. Handrails, so forth, makes it nice. So without pulling and distorting as you're welding along and fabricating. Moving on. Few advantages of GMAW welding. Welders proficient in other welding processes can be readily trained in the GMA process. And I'm going to agree with this, I'm going to disagree with this. FluxCore, yes. If you're pretty good with shielded metal arc welding electrodes, FluxCore is not going to be much of an issue with you. They're very similar processes. In my opinion, FluxCore is a lot easier than SMAW. GMAW is easier than SMAW as well. However, when welding with GMAW, there are a few techniques that we need to make sure if we're doing a critical weld. A lot of times you can make a nice looking weld and it'll be good, but if you were to destructive bend test that weld, I've seen time and time again welders that have come in and been welding for years on light fabrication, but they've never really tested their GMAW welds. They'll come in and they'll have not the correct technique. They'll weld something up and we'll go to bend it and it'll completely just bust apart because they didn't clean it enough. You know, they just thought they could weld right back over it and they could, without grinding. You need to grind down. That top layer of metal has a little bit of silica within it. And I've seen time and time again to where you lay a weld bead down like this, you put another one on top of it without grinding it, And when you go to bend it, the two pieces, the two welds come completely apart because that top 2 or 3 thousandths of an inch on the layer of this weld has got a lot of silica within it, okay, as it solidifies. Now if you grind that down just enough, just to take it back to what in the trade, and we usually consider it to be a clean white metal, it'll go from, if you buff it, it's kind of silver, but then if you hit it with a grinder, it takes it to like another shade of white metal, okay? So we say grind it down to clean white metal, weld back over it every pass. Now you don't have to grind the whole thing out, just knock that top layer off. So a lot of people come in, they get frustrated when they're first starting, they'll almost grind the whole weld back out. You don't need to do that, you just need to knock the top layer off of everything, wire wheel it, keep it clean, come back in and weld it again, okay? Several of my colleagues, amazing welders, I have seen them have trouble with that exact situation on a pipe welding for a drag line that we worked on. So once they changed our technique up a little bit, made sure to grind every pass in between, they passed without with flying colors. So welders can weld as fast as they are able. Well, again, make sure welders can weld as fast as they can produce a sound weld is how I would like to see that written. No welding slag or flux to remove when solid wire or metal cord wire is used, and weld spatter in the minimum. Again, if you're doing a single pass weld or something that's not a critical weld, yes, this is true. But if you're doing multi-pass welds on something that's going to see vibration, impact, static load, and things of that nature, I would like to see you grind in between each weld pass. Keep it clean. It takes a second, 2 grinders, and weld back over it, okay? Welding may be done in all positions on both light and heavy gauge materials, absolutely. Concentration of current, higher for GMAW than for stick electrode welding. Yes, however, laws of physics do play in here. If you'll notice, you'll also notice that you're not putting as much heat input into it as well. So concentration of the currents on a smaller piece. On shielded metal arc welding, it's a larger portion. However, it's just because you're seeing a higher concentration of current doesn't mean that your GMAW is hotter than your SMAW. SMAW is still a deeper penetrating welding process, okay? GMAW short circuit transfer is the coldest welding, arc welding process known. So much so that the American Welding Society will not allow any pre-qualified welding procedures for GMAW short circuit. So every time you want to write a procedure to say this is code quality, it's got to meet a spec, we want to weld it up with GMAW short circuiting transfer, which is what most of us are familiar with in the shop. You're going to have to prove it every time. You're going to have to prove technique, voltage, amperage, base metals. You're going to have it sent off to a lab, tested, and so forth. At this point, we don't have the machine to test the tensils, but I think in the future we will look forward to doing some situations like that here at COCC. Okay. So again, this can be somewhat misleading. I just wanted to explain the difference. Just because it's a high concentration of current doesn't mean that it's a